Okay, so our next chi-squared we're going to talk about. So we as part of a survey, we have students in large stats class were asked whether or not they ate breakfast that morning. And notice that they broke it into two different groups, male and female, yes and no. Realize this is categorical again. Categorical data is for chi-squared. The grades were categorical data. So we have all of a comparison. We have 331 total students. Okay, notice I've created a matrix here of the observed yes and no, male and female. And I've put them into this. We put them into a matrix. I'm about to show you how to put it into a calculator. We're going to find an expected matrix, but I'm not going to do that until after I get down here on the bottom part of the page and run the test. When I run the test, the calculator is going to create that for me, and life will be oh so good. So let's look at some stuff here first. Notice it says, is there evidence that eating breakfast is independent of the student's sex? Okay, independent is synonymous with saying there's no association. In other words, we're thinking eating breakfast has no association with the student's sex. And it says test the appropriate hypothesis, give statistical evidence. So that means we're going to do a hypothesis test. In this case, we're going to do one for independence if our conditions are met. So eating breakfast is independent of the student's sex. That is our null hypothesis. Our alternative hypothesis is eating breakfast is not independent of the student's sex. Remember, one makes the statement, the alternative disagrees with that statement. Our alpha is still 0.05 and our degrees of freedom is 1. You're thinking, wait a minute, Pruitt, why is degrees of freedom 1? Okay, to determine degrees of freedom for a test of independence, we're given a table. We mark off this row, we mark off a column, and whatever's left, in this case, a singular number. If we marked off these numbers, we marked off these numbers, there's a single number left in our matrix. So we could look at it this way. We can mark off this and this. We just have one number left. So the degrees of freedom is 1. These marginal distributions do not count in our matrix, nor in our determination of degrees of freedom. All right, so let's look at first how to put this into a calculator, how to create a matrix. All right, if you'll notice, there's the word matrix right there above. That shows up nicely on my screen. That right there with the x to the -1 power or the inverse button. So I'm going to press second matrix, and I'm going to go over to edit. You need to write these steps down. Second matrix, go over to edit and press enter because we need to create the matrix. Well, let's look at this matrix. It has 2 rows. Rows come first, RC, rows, columns, Royal Crown. So 2 rows and 2 columns. Rows go across, columns are vertical. So this is a 2 by 2 matrix. And then we press enter and it says, okay, well, what are those numbers? So I type in 66, enter, 66, enter, 125, enter, 74, enter. And now we're done with that. So now to clear a screen, to clear the screen, you press second mode. If you look right above the mode button there, it says quit. And that clears our screen. Now, that stuff's still in there. Whoops, sorry. Let's go look. Second matrix, look, it's still there. It's still there. So we don't no need to worry about that. Again, we're going to do this in a moment. So these weren't a random selection of students, but we're going to assume they're independent of each other. There are people who may go to lunch or breakfast because someone else is, but we're going to assume that they're all independent. 331 is less than 10% of all the students. And we're going to expect, with such big numbers in here, we're going to expect that all of our counts are greater than or equal to 5. And so it says independent. So we're going to do a chi-squared test for independence. I'll remind you once again, independence is the same as saying no association. So we have chi-squared, whoops, sorry, let me adjust my screen here. We have chi-squared equals the sum of the observed minus the expected squared over the expected. Well, we need to find this sum. So let's run the test. So stat, test, and we go up. Now we've done the goodness of fit. Now we're going to do a simple chi-squared test. Okay, chi-squared test for independence. Look, observed is in A, expected is in B. We haven't put anything in B, but that's okay. It's going to create B for us. This is so cool. It wasn't until a couple of years ago that I found this out. So we calculate. Okay, there's our chi-squared is 5.34. I'm going to round because of that 9. I'm going to put 5.34 here in my probability. The probability of chi-squared being greater than 5.34 is 0.021. I rounded that up. Look, degrees of freedom is 1. It tells us that. If you don't remember this, when you run the test, it tells you and you write it down because the College Board expects it. Okay, p-value is 0.021. That is smaller than alpha. But we haven't done this yet. But we can go ahead and do this. With such a low p-value compared to alpha, 0.021 compared to 0.05, we reject the null hypothesis. There is evidence, notice I didn't say strong or even very strong, because my p-value is only 0.02, the evidence that eating breakfast is not independent of the student's sex. I'll make this statement again. If we reject the null hypothesis, then we write the alternative. If you reject the alternative, if you reject the null, then write the alternative. There is evidence that eating breakfast is not independent of the student's sex. Okay, the only thing we got left to do now is to write this one in because they expect that. I keep pressing stat, second matrix, the second one there. We got to edit so that we can see it. Okay, and here's our numbers. Whoops, 76,169. 55.831. Do you see why I didn't put walls on that matrix, brackets around it? Because I wanted to make sure that I could fit all these numbers in here. And yes, you got to put all of these decimals. Okay, put all of these decimals. Unless there's a repeating or something, then we might write an improper fraction or something or a mixed number. Oh, you can't see them, can you? Sorry. There we go. There we go. So there's our expected matrices. There is our observed. Again, all of these are greater than or equal to 5, so that worked out nicely for us. We found our p-value, our chi-squared when we ran the test and our p-value, and then we wrote our conclusion. Okay. I hope if you have any questions, you'll let me know. Otherwise, I hope you enjoyed that video and it was helpful. Hope you have a great rest of the day.